one, what do I do? Find a common denominator, right? Okay, so what is my common denominator? X minus 2 and x plus 3. So the first one was 2, the second one was 5. So now I've got to adjust, correct? Okay, so if I adjust the first one, what do I have to multiply the numerator by? X plus 3. If I adjust the second one, what do I have to multiply the numerator by? X minus 2. Okay. Then I do some cray-cray distributing. And so on top, I get 2x plus 6 plus 5x minus 10 all over x minus 2x plus 3. Yes? Okay. Top then becomes 7x minus 4. Can anything be factored out of 7x minus 4? Nope. So then that bottom becomes x minus 2 and x plus 3. So that is my answer. Let's throw some restrictions on there just because we can. X cannot equal what? 2 and negative 3. Okay? Second one, but really it's the third one, Vincenzo. Okay? What do I have to do first? Flip this last one, right? So this becomes 3n. Oh, whoa, tap the brakes, child. This becomes 3. Whoa, tap the brakes again. Wrong color. Rumba. 3m squared n squared. I'll get it right one of these times. Divided by 10 times m squared over 8n times 20 over 3n squared. Okay? So we flip and switch it to multiply. Now what? Okay, what can I cancel? The n squareds. That one and that one. The 3's. 20 and 10. So what goes where?
The 10 will be reduced to 1 and the 20 will be reduced to 2.
Okay.
Oh, no, the 8 and the 2.
Okay, so what becomes what?
The 8 will become 4 and then the 2 will become 1.
Anything else? Okay, so the top becomes m cubed and what? Nope. Multiplying. Okay. And the bottom is 4n. Okay. Restrictions. There's no x in this problem. So we've got no restrictions on x. N cannot equal 0. And that one comes from this denominator right there, right? What are the other 3 spots that I have to look?
The bottom 2.
The other, so this one right here, any restrictions from 10?
No.
Nope. Any restrictions from 20? Nope. And then I also have to look up here, right?
Yeah.
Because that one becomes a denominator down there, and that one's just going to give me n equals 0 again. Right? Jackie, question or stretching? Okay. You kind of gave that look like you were going to ask a question, but I was still talking, so you didn't want to interrupt. You know what I mean? Okay? Yeah, buddy? Fifth one, but Vincenzo is really the third one. Okay? Or third one, but it's really the fifth one. Okay? What are we going to do first? Flip. Before we simplify, we've got to flippa. Okay? X squared plus 4x plus 3 over 2x squared minus 11x plus 5 times then 2x minus 1 over x squared plus 3x. So I flippity floppity. Now what do I do? Factor. Upper left.
X plus 1 and x plus 3.
X plus 1, x plus 3. Everybody agree? Good. Lower left. 2x minus 1 and x minus 5. That one. Upper right. Lower right.
X plus 3.
Okay. Now I can start crossing stuff out. X plus 3.
2x minus
2x minus 1. Oops, I forgot to cross out that one. Okay. Is that it?
Yep.
Okay. So, then that would give me, on top I'm left with
X plus 1.
x plus 1. On the bottom I'm left with
X minus 5.
x and x minus 5. Restrictions?
X cannot equal 5.
X cannot equal 5.
X cannot equal
Negative 3.
Yep.
1/2. And 0. Okay? So let's check to make sure we got them all. Okay? So this denominator here, this is this one, so that's my 1/2. And this one, so that's my 5. So I got those two. Okay? This denominator here is 1/2. Got that one. Then this denominator, which was really this top up here, gives me 0 and negative 3. Got them all. Bada bing, bada boom. Okay? Fantastic. Now, what you are going to want to do is you are going to want to take out a separate sheet of paper. Okay? We're going to be kind of in the book, so have your books open and out, but at the same time, it's just going to be easier for you to just do this on a separate sheet of paper. Okay? So, we be switching from rational expressions. All of these from before were what are called rational expressions. Okay? Now, we're switching to a rational equation. Okay? So, my question to you is this. What is the only thing that you can do with a rational expression?
Cross multiply.
No. Can't cross multiply a rational expression. What's the only thing you can do with a rational expression? Simplify. That's it. That's what you've been doing up to this point. You've been dealing with rational expressions. Okay? Now, what's a rational equation? It's got an equal sign in it. Okay? Equations have equal signs. So what can we do with them, Max? Now we can solve them. Okay? This is fun stuff. This is stuff that just makes you want to get up in the morning and go, woo! Good to be alive. Okay? Alright? Okay? Don't even go there, dude. Okay? Don't even go there. Alright? Okay? Oh yeah, big time. Okay? Alright? So that's what we're doing now. Okay, so now we're actually going to get x equals 92. Okay? X equals negative 9/4. Okay, we're going to come up with actual real live answers. Okay? So there's two, but we call it three methods to solving rational equations. Okay? The first one is limited. It's everybody's favorite cross multiply. Okay? Now that we have an equal sign, we can finally cross multiply. Okay? But cross multiplying is limited in that you can only use it if it is fraction equals fraction. If you have more than one term on one side, you cannot cross multiply. Okay? It's got to be a single fraction equals a single fraction. That's the only time that you can cross multiply. Okay? Now, one other kicker in this is we're going to add a step to your process. And really, it's going to be like step 0. After you look at the problem, it's the next thing that you do. Okay? And that is, we're going to have you state the restrictions first. We used to have been doing the restrictions at the end. Okay? Because we were just saying, well, if this were, this is just where this function doesn't exist, kind of a deal. Now, I'm going to have you start with the restrictions because of this thing called extraneous solutions. Okay? Now, there's a paragraph on page 624 that deals with extraneous solutions. Okay? An extraneous solution is an answer that you get at the end of the problem, but when you would plug that one back into your problem to check your work, you'd get a non-true statement. Okay? It's an answer that you get, but it doesn't work out. Okay? Because 9 times out of 10, it's part of your restrictions. Okay? So if you list the restrictions first, then if you get one of those answers at the end, you can throw it out. Okay? Because it's not going to work. It's part of your restrictions. Okay? So, what are the restrictions in this particular problem? So x cannot equal -2 or +5, right? Okay? So in the end, we're going to solve this problem in about 4 seconds. Okay? In the end, Ruby Tuesday, if we got x equals 5 as our answer, we kick it out. We throw it out. Okay? And then if we had some other ones, then those would be the answers. Okay? But that one wouldn't be part of it. Or if that was the only answer we got, and if it was 5 in this particular problem, we throw it out and we say no solution. Okay? Right? So, cross multiplying. Oh yeah, about time. Okay? So, we take and we multiply those two together. Right? So that becomes x plus 5 times x minus 5. Okay? Then, that's going to equal. Then I take those two. And multiply them together. Okay. With me? Now, let's do some math. God, I love this stuff. Left side, what does left side become? You started and then you tell
X squared minus 25.
x squared minus 25, is that what you said? Okay, because it sounded like you said x squared plus 25 there for a second. Right side, what does it become?
X squared plus 3x plus 2.
Agree with x squared plus 3x plus 2. Yes? Okay. Now, we got to think back to all of our algebra wonderful learnings. I have a squared term somewhere in my problem, right? When I have a squared term somewhere in my problem, what do I have to do?
Square root 8.
No. What do I have to do? No. When you're solving, and I got an x squared, what do I have to do? Not yet. Got to do something before I can factor. What? What did you say?
I was saying set it equal to 0.
Well, that's the right answer. That's why I was trying to get you to say it, my man. Okay? So I got to get everything onto one side, right? Okay? So let's start with moving the x squared. Right? Okay? So now I've got negative 25 equals 3x plus, whoa, where'd my x squared go? Went away, right? So now my mathematical, what I need to do next, changes. Now I don't have to get everything onto one side. Now what do I have to do?
Minus 2.
Just wait. So I gotta get x on one side, numbers on the other side, right? Okay, so what do you got, Ben?
Minus 2.
Subtract 2 from both sides. So negative 27 equals 3x. Okay, then what?
Divide by 3.
Divide both sides by 3. Oops, I put negative 3, but we'll just go with array. Okay, so x here equals what? X equals negative 9. Is that one of my restrictions?
No.
No, so I'm good with that then. I can check this, and if I check this, I should get the right answer. Okay? So let's do a quick check. It might only take 10 seconds. Negative 9 plus 5 over negative 9 plus 2 equals negative 9 plus 1 over negative 9 minus 5. Negative 9 plus 5 is negative 4. Negative 9 plus 2 is negative 7. Right? Negative 9 plus 1 is negative 8. Negative 9 minus 5 is negative 14. Are those two equal? Sure. They're not the same numbers,
Oh, yeah.
but they are equal because if I divided this one by 2, I'd get negative 4, and divide this one by 2, I'd get negative 7, and now they are equal. Right? Now, I walked us through that check, and that took, what, 15 seconds? Okay? right? And I wrote it all out too. You could have probably done the negative 9 plus 5 in your brain. You know what I mean? Okay? So it doesn't take you very long, and you know that you're right. Man, that's awesome. Okay? Being right is so much better than being wrong.
I know.
You know? Good is so much better than bad. Okay? Okay? Right? Before I forget too, don't forget that Friday is homework and formative day, whether or not you have class or not.
So this
Okay.
yesterday.
I know. Yeah. But I'm reminding you. Yeah. Yeah, that was before I forget, so you don't forget. Okay? Try it. Try it, and you will see. Alright, so this one factors to be what? X minus 4 and x plus 2. Right? And this one factors to be 2 times x plus 2, right? Right? Okay? So right off the start, my restrictions are x cannot equal 4 and x cannot equal negative 2. Yes? Okay? So, oh, look at this. So now when I cross multiply, I only got to do 2 times x minus 4. And that's going to equal I did the same color. Oh well. That's going to equal x minus 4 times x plus 1. Okay. So that gives me 2x minus 8 equals x squared minus 3x minus 4. So that's going to give me 0 equals x squared minus 5x plus 4. Factor. X minus 4, x minus 1. Then I set x minus 4 equal to 0. That gives me x equals 4. I set x minus 1 equal to 0. That gives me x equals 1. Do I like both of those answers? One of them is in my restriction, right? So I get rid of that one because x cannot equal negative 4. It says so right up there. So that leaves me with x here equals 1. What? So, see, now what I did in the other class is I went from my purple line here, okay? I divided by x minus 4 on both sides. And so then I got 2 equals x plus 1. Subtract 1 from both sides and x equals 1. Okay? Alright? But Rubes, doesn't matter. There's plenty of ways to do these problems. You know what I mean? Okay? Talked about extraneous. Okay? So, method number 2 and method number 3. Okay? Again, they're both kind of the exact same thing. Okay? So, I'm going to say over here, I'm going to do method number 2. Okay? And then over on the other side, I'll do method number 3. In the end, we'll probably hopefully get the exact same answer. Okay? So, in this particular method, what we're going to do first is we are first going to get rid of the fractions. So that means that you are going to multiply all the terms by the LCD, by the least common denominator, okay? Right? Or by the common denominator, if you will, doesn't matter. Okay? So, thinking of the numbers 6, 3, and 12. What is the least common multiple, if you will, LCM? Let's go LCM instead of LCD. What is the least common multiple of 6, 3, and 12? 12 is. Okay? So I'm going to multiply this term by 12, this term by 12, and that term by 12. I'm going to multiply by 12 in 3 spots because I've got 3 terms. Okay? So, in my first one, 12 divided by 6 is 2. So this becomes 2 times 3x plus 2. $12 divided by 3. 4. So this becomes plus 1 times 4. 12 divided by 12. 1. So this becomes 2x minus 1. So, 6x plus 4 plus 4 equals 2x minus 1. Okay? Right? Now I'm going to pause for the cause right there. Okay? And I'm going to show you method number 3. Method number 3 says I need to get it in common denominator form. Right? Okay? So what is my common denominator between 6, 3, and 12? 12 is my common denominator. Okay? So on top here, this one was 3x plus 2. What do I have to multiply to adjust that first fraction by? Got to multiply by 2. What this next one was 1. What do I have to multiply that fraction by? From 3 to 12, I've got to multiply by 4. Okay? And then my last one was 2x minus 1. Right? And that one's already in my common denominator form. Right? Yep. I was just calling down to figure out, is she okay or?
Yeah.
Okay. Okay. Okay, right? Then, once you find the common denominator and you've adjusted your fractions, you forget all your denominators. Okay? So this would just become 2 times 3x plus 2 plus 1 times 4 equals 2x minus 1. Where have you seen that before? It's right there. Okay. Yeah, those two lines are exactly the same. Which then means that this would become 6x plus 8 equals 2x minus 1. Okay? Because it would be 6x plus 4 plus 4. 6x plus 8. Okay? So then, let me rewrite it here now. Let me go. What would you do next? If you're at the same time as you're subtracting 2x, what else can you be doing? How about subtracting 8? Okay, so then that gives me 4x equals negative 9. So x here equals negative 9/4. Now, one thing we didn't do at the beginning of the problem is we didn't do our restrictions, did we? Are there any in this problem? No, because there's no variables in the denominator, no restrictions, so there is our answer. Okay? Want to try one on your own? Sounds like a great plan. Okay? I'll even help you along. Okay? I'll factor that one, and I'll give you what the restrictions are. X cannot equal 0. X cannot equal 4. Okay? Solve that bad boy. So on the left, I have it set up for method number 2. On the right, I have it set up for method number 3. Okay? So my least common multiple, or my least common denominator, if you will, would be x times x minus 4. That would also be my common denominator over there. Okay? On this side, when I multiply by those go away. I'm left with 6. When I multiply by x here, I'm left with plus 4 times x minus 4. When I multiply by that over here, I'm left with equals 2x. Okay? Alright? If I go over there, now that I've got the common denominators and I've got them adjusted, I'm left with 6 plus 4 times x minus 4 equals 2x, which those are the exact same line. Okay? So then from there, that would be 6 plus 4x minus 16 equals 2x. Okay? So then that would be, I would subtract 4x from both sides. So then that gives me negative 10 equals negative 2x. So that gives me 5 equals x. 5 was not one of my 2 restrictions, so 5 is my answer. Questions on that one? Yes, ma'am.
One way done is x equals 4, then multiply for this answer.
No solution. Yep. Okay. Exit ticket for today. On the back side of your note sheet that we gave you, I would like you to do number 2 on the back side of the note sheet that we gave you at the beginning of class. This number 2. That is your exit ticket today. You too.